David Smith here with one more flipped classroom math video. 3 tips before we start. First, remember you can speed up the playback if that helps you get through the video faster. Just make sure you understand and keep up with your notes. Second, you can pause the video at any time to catch up with your notes or think about the topics. Lastly, you can turn on the captions and watch my words go by on the bottom of your screen. Today's video talks about measures of central tendency. And we're in the middle of a statistics unit where we like to talk about or develop ways of talking about large groups of numbers. And this allows us to understand those groups of numbers and make decisions based on those. So measures of central tendency, we have 3 fundamental things that we can calculate, and they are mode. This is the value that occurs the most frequently. Median is the number that lies in the middle of the data set. So half the data is below the median and half the data is above the median. And then lastly, we have the mean or average. This is where you add up all the numbers, you divide by how many you have, and that's the mean. So these are 3 different ways of talking about central tendency. Okay, so let's put these ideas to work. Here's our first scenario. Here are a bunch of test scores. I got 14 different test scores. Now we might want to talk about these to talk about maybe how did the class overall perform, things like that. Now just looking at those 14 scores, it's kind of hard to say a lot about that. So our first step is going to be write down the mode. Remember your IB keyword, write down, that means something specific, and then you've got mode over there, the definition thereof. So go ahead and pause the video and figure out what the mode is. Okay, the mode is 58 because the 58 happens 3 times. We have a 58 there, we have a 58 there, and we have a 58 there. No other number appears 3 times, so 58 is our mode. Okay, now I'm going to ask you to find the median. And now there's a trick for this, but I'm not going to explain it first. I want to see if you can do that. So go ahead and pause the video and figure out what the middle value of these test scores is. Okay, the special trick is to write the test scores in order. That's really the only way we can know the median. So now I've got all 14 scores written down in order. Let's just count out 1, 2, 3, 4, 5, 6, 7. So the middle is right there. Now, there is no median value. We're halfway between 66 and 67. So the median is going to be 66.5. Last one for this example. Calculate the mean. Now I'm going to stop you now. I want you to go ahead and do that yourself. So calculate your mean and let's see what you got. All right, so I want to explain something I forgot in the very beginning. I did put this equation down here. So let's take a look at that. X bar is a symbol that we can use for mean. So that's a common symbol in mathematics and statistics. And what X bar is it's sigma over n. Now, sigma is the sum of the data. So you add up all the data, all the values, you add them up. So sigma is the sum of the data, and then n is the number of values. So it's sigma over n is going to give you your X bar or your mean. So go ahead and, if you haven't done that yet, do that. All right, so my sum of my values, I just added them all up. I got 924 for that. Cool. Now, X bar, our mean, is going to be 924 divided by 14 because 14 is our n. We have 14 pieces of data in this sample, and so my mean is 66. Now, here's some good news. Your fancy calculator will do all these things for you. So I posted some links below in the comments, one for the Ti-84 and one for the Ti-Nspire. So you don't have to actually manually add up all these numbers. You just enter them in there. And then the calculator is going to tell you all kinds of good stuff about it, including more measurements that we're going to use a little later in this chapter. All right, let's move on to another example. But this time we're going to use a frequency table. We used those in the last lesson. So let's do that. This is a frequency table for the number of candies in 20 different bags. So we have 20 bags of candy. And then the way to read the table is that we have 2 bags with 23 candies. We have 3 bags with 24, 9 with 25, 1 with 26, and 5 with 27. So first off, I'm just going to ask you, what's the mode for this data? Okay, let's see how you did. 25. There's more bags with 25 candies than any other number of candies. So our mode is the 25. All right, now let's do a little bit more complicated one. Now we want to find the mean, okay? So that's the mean number of candies in bags. Now, this table is kind of abbreviated. It's a frequency table. So we know we have 2 bags of 23, we have 3 bags of 24. So the way to solve this one is to create another column, like so, and we're going to calculate the total number of candies for each type of bag. So this column is going to be total candies, and what it will be is it'll be the frequency times the number of candies. And that makes sense because we have 2 bags with 23 candies in them, so that means we have 46 candies here. And we're going to need to complete that for our whole table. So go ahead and do that. Okay, so I just went ahead and did the multiplication across, and I have my total candies in each type of bag. So for example, I have 225 candies total when I'm adding up all the candies, all the bags that have 25 candies in them. Now we need to total all of these up. So how many different bags do I have? Well, my frequency tells me I have 2 bags of 23, 3 with 24, and so on. That's a total of 20 bags of candies. And then if I add all those up, they come to a nice round number. That's 500. So I have 20 bags with 500 candies total. So what's the average for that? Pause the video, do that calc. So remember our formula. The mean, x bar, is the sum over the number of values. So our sum in this case is 500. We have 500 candies total, and our number of value is 20. So we have 500 over 20, and that's going to give us 25. So that's the average number of candies in a bag. And it kind of lines up with our mode. So they're kind of in the same place. Okay, so you can also use a frequency table in the fancy calculator. So I'm going to post some links for that as well in the bottom of the video. So there's probably going to be 4 or maybe even 6 different links depending on which calculator you use. Those will show you what you need to know. One last example. This one is an interesting one. This is a frequency table for the weights of 50 cats. Okay, so we weighed 50 cats, and here's what we got. Remember, before we do that, what kind of data would cat weight be? Discrete or continuous? If you said continuous, you're right. Unlike a test score where you had a 58 or a 92 or a 67, cat weights can be all over the place. They're decimals and so on and so forth. So the way we expressed our weights in a frequency table is we said we had 5 cats that were greater than or equal to 2 kilograms but less than 3. And then we had 9 cats between 3 and 4, 17 between 4 and 5, and so on. So we had to express our weights in terms of ranges so that we could get frequencies. Otherwise, it would be very likely that we just have one weight, one measurement for every possible weight, especially if we used a scale that measured like to the thousandth of a kilogram. You wouldn't get any doubling up. So here's our weight classes, our ranges, and here's our frequency table for those ranges. Now, this time I'm going to have you do this calculation in your calculator, but there's one thing you're going to need to do first. What are you going to enter for weight? You're going to use the frequency table feature for doing your calculation, but you don't have actual weights. You know that there's 5 that are between 2 and 3, but you don't know what those 5 are. So here's what we do with that. We make a midpoint column, and we put the middle point between the 2 ranges there. So the midpoint for that would be 2.5. That's the midpoint between 2 and 3. This would be 3.5, 4.5, 5.5, 6.5, whoops, that's a 5, and 7.5. So now when you go to your calculator and use your frequency table to generate your median and your mean, you're going to use this as the value and this as the frequency. You can't put that in there. So you're going to have to use your midpoints. So what I want you to do, pause the video, and if you haven't watched the video about how to use a frequency table to calculate mean, median, and mode, you want to watch that video, maybe pull that up, and then use these notes to enter in your data and calculate your mean and your median. All right, so I hope you found success with that calculation. If you didn't, maybe go try that one more time, because this is a super essential feature for the fancy schmancy calculator. So here's what happens. Here's what I get. I get 4.6 kilograms for our mean, and I get 4.5 kilograms for our median. Now remember, the mean is the average weight of all these 50 cats, and the median is the weight for which half the cats weigh less and half the cats weigh more. And that's our 4.5 kilogram value. Now that you've watched the video, take a moment to write down any questions so you can bring them to our next class. Always remember, you can watch the video again to deepen your understanding. If you enjoyed the video, please click like and subscribe.